15? Okay, so this is page 15, and we're going to go over how to do the panic and the phantoms. So we're starting with this first example on Andre, who's a waiter in San Francisco. The IRS is going to do a tax audit on him. So they want to know what his average amount of tips that he got last year are. And so in an effort to satisfy what the IRS did, he took a random sample of 8 credit card receipts. Now, first, me telling you that he's got 8 credit card receipts, that should be kind of like making you kind of get a little nervous. Why would just 8? It's so small, yeah. So that kind of potentially causes a problem. But we gotta watch out for that and see what's going on. Now, it says the sample mean is 1235. And I want to ask you, what symbol would represent sample mean?
X with a line over it.
X bar, very good. X bar is the sample mean because we would use mu. We would use a mu to be the whole population mean. Okay, very good. And then the sample standard deviation is 225. So that's the S with the little x. And that's 225. All right. Assuming the distribution of tips is unimodal and symmetric, which is approximately normal.
So that takes
Ding, 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 ding. So that takes care of the problem that it's a small sample size. So we like that. And all the conditions have been met. See, I'm teaching the conditions tomorrow. And so therefore, you're not going to do any of the conditions on this assignment here, okay? So find a 90% confidence interval for the population mean of tips that he receives. So let's start a panic model because it's asking us to do an interval. So I'm going to take the first, what does P stand for in the panic model? Population parameter. And this is not about a proportion. It is about a mu, which is the average of all Andre's tips. So average of all Andre's tips. Okay, so making sure that we're using mu because we're so attuned to using proportions. All right, what comes next in the panic model? A, which stands for the assumptions, and we are good to go on that. They are checked off. What does N stand for? The name of what we're doing. So let's think about this. What do we got going on? How many? We have one sample, but it's not a proportion. It's a mean. So we have a 1 mean T interval. Okay. Now we're going to make the interval. And so I want to have a little discussion with you about this situation, about making this interval. And the discussion, I'm going to use some blank paper over here. The discussion comes from this. On your formula chart, there's a generic thing that is written out for intervals. And it says that an interval, on the formula chart, it says this. An interval is a statistic plus or minus your critical value times the standard deviation of your statistic. Now, let's see what we have been doing that with. We have done that with a proportion. So when we did a proportion interval, what was the statistic that we would have? It's a sample proportion. That's your p hat. Very good. So the formula we used for a proportion interval, we had a p hat plus or minus, and then our critical value was a z star. Good. And then our standard deviation was that square root of p 1 minus p over n, which we use p hats if we didn't have the p. Okay, good. Well, now we're going to do it with means. So the mean statistic, what is the sample mean? What letter is that? That's our x bar. Very good. So our formula for the interval for means is x bar plus or minus, and it's not a z star anymore. It's a t star. Very good. Now, also, if you remember from way back in chapter 18 when we did a mean problem, the standard deviation for means was the population, or the samples, in this case it'll be the sample standard deviation divided by the square root of n. So we'll have to be doing that now. So that's our formula, x bar plus or minus t star times s of x over n. So that's what we're going to do to get our information over here. So let's go ahead and fill that in over the square root of n. So that made 1235 plus or minus. Now, do you remember how to get this t star? Inverse, not inverse norm.
I mean,
Yeah, inverse t of 1 tail, comma, degrees of freedom. Well, degrees of freedom.
yeah,
It-
but it's n minus 1.
If it's a 90% confidence interval, then 90% is in the middle, so don't you dare go inverse t of 0.9. Do inverse t of what? 0.05. Because 5% is what's in the tail. So I'm going to get this by going inverse t of 0.05. What was the degrees of freedom if there are 8 pieces of data? 7 degrees of freedom. And then this standard deviation would be that 225 divided by the square root of 8. Now, I'm going to go ahead and tell you the answer to this interval. I'm assuming that you could do that. It goes from 1084 to 1386. Ooh, and I forgot to tell this to everybody yesterday. You know what else I forgot? You always have to tell them which curve you did your calculating off of. So what was our degrees of freedom? 7, yeah. So that always has to be included when you do a panic or a phantoms with means. A panic or a phantoms with means has to include the DF. Okay. Now, the last thing that's missing is our what? Conclusion. So how are we going to start that? I am 90% confident that and what's this about?
Average of all.
Good, the true average of all Andre's tips is between 1084 and 1386. Okay.
So you don't have to do anything about the degrees of freedom in the conclusion?
No, you don't have to, just as long as you marked it with your computing.
Okay.
All right, so now let's go do a hypothesis test. So because the next page, example 2, says to test the claim, the IRS, see, Andre, he claimed $10. He said his average was $10. The IRS says, I don't think so. They think Andre makes more than $10 per tip on average. Okay, so we're going to do a hypothesis test, and so we're going to do a phantoms. Okay, the parameter P stands for parameter in phantoms, and that's the same. So let's just write that's the same. H, what does that stand for a hypothesis test?
H-O.
Good. H-O colon. And, well,
Oh.
H-O, then the colon, and then what are we saying? What is our null hypothesis?
His average is equal to what you told me.
To 10. So mu equals
Oh, sorry, I'm
$10.
so confused with the ones that we were doing number 2.
And H-A is
Mu is greater than $10. Very good. So we're going to see. Now, I want you guys to kind of just use your brain for just a minute. And I want you to think about this interval conclusion we had made. We were 90% confident that the average is between 1084 and 1386. So what do you think, if you had to guess, what do you think you're going to be doing to that null hypothesis? Yeah, I'm probably going to be rejecting it. Why do you think you're going to be rejecting it?
Because the interval does not contain 10.
Because the interval does not contain 10. The entire interval is above 10. Yep, very good. So let's see if that ends up happening. Good job. Okay, now with A in the phantoms model is the assumptions, and we don't have to do those. N in the phantoms model is the name of what we're doing, and that is a one mean
C.
T test. Because we're doing a hypothesis test, yep. One mean T test, okay? All right. Now, T is your test statistic. That used to be a Z-score. when we did p hat minus the p over the standard deviation of p hats. But we don't do that now. We do a t-score. And so, what do you think would be equivalent to a p hat, but with means?
X bar.
X bar, very good. So that's going to be X bar minus the population mean, because you're seeing how far away your sample was from the population mean, over the standard deviation of those things. So when we fill in those blanks, let's go ahead and do that. T equals 1235 minus 10 over, and that was 225 over the square root of 8. So that's your values that you got there. That ends up being 2.94. So your t-score, that means your sample is more than 2, almost 3. Is almost 3 sample standard deviations of the square roots of 8 out there. Okay? All right. Now, so that's the test statistic. O in the Phantoms model means obtain a p-value. So, you know, here I've got my sample out here, 2.94 stuff out here. The p-value is that area. So how do I get that p-value? Do you remember how we used to do that? We used to norm CDF, but now we TCDF. Good job. So I'm going to TCDF from 2.94 to 99 with 7 degrees of freedom. That comes out to be 0.011. 0.011. So what is that we just figured out? What is 0.011?
Our p-value.
That is your p-value. Very good. So let's write that. P-value equals 0.011. That is less than alpha of 0.05. And we did that with the degrees of freedom 7. So remember, so our M is to make a decision, and we will reject HO. So now S is our conclusion, and we say, since 0.011 is less than 0.05, I reject HO. And then what do I say?
There is evidence
There is evidence to suggest that
he makes
the average of all Andre's tips
is greater than 10.
Is greater than $10. So yeah, I would say the IRS would be able to audit him and ding him and fine him. Now, do you think they're really going to do this on a little waiter from San Francisco? No, but this type of concept is used for like biggest businesses, you know, that are trying to pull a fast one. Yeah, so they would do that kind of a thing. Yes, All right, so then your assignment is we already had done the first 5 problems on page 17. So your assignment is to, numbers 6 and 7 are both panic models, and conditions don't have to be done on any of these ones from that homework. And then on the next 2, numbers 8 and 9 are phantoms, 2 tests. So you had 2 panics, 2 tests, and there was no assumptions on those ones.
Sweet.